All right, let's get right into it. We think of electric vehicles as these super advanced, efficient machines. But what happens when you take that piece of high tech and drop it into one of the most extreme climates on the planet? Well, that's exactly what's happening in the Gulf right now. And believe me, it is forcing a total rethink of how these cars are made.
For the longest time, the big race in the EV world was all about efficiency. How can we squeeze every last mile out of the battery? How can we cut down charging times? But in a place where the roads can literally get hot enough to melt, the word endurance suddenly becomes way more important than efficiency. It's about survival.
It's a pretty wild question, right? Because the answer isn't just, oh, the battery drains a little faster. No, we're talking about batteries aging way too fast, core systems failing, and some pretty serious safety risks. The crazy part is, the solutions they're coming up with in the Gulf might just be the blueprint for the future of EVs everywhere.
So here's how we're going to break it all down. First, we'll look at why the desert is basically a nightmare for electric vehicles. Then, we'll dive into how the region is literally rewriting the rules for them. After that, we'll check out the cool new engineering that's coming out of this, see how they're making sure it all works long-term, and finally, wrap up with why this isn't just a local story, it's a plan for the rest of the world.
Okay, so let's start with the absolute heart of the problem. In most places, EV engineers are obsessed with range. But in the Gulf, when the thermometer blows past 45 degrees Celsius, that's 113 Fahrenheit, heat becomes the #1 enemy. It's the main thing they have to design for, and it changes everything.
And this slide just lays it out perfectly. Look at the priorities. In a market like Europe or the US, it's all about range, how fast you can charge, and the cost. But for the Gulf Cooperation Council, the GCC, it's a completely different list. They're focused on resilience to heat, absolute safety, and whether the whole system can be relied on when it's under constant, brutal stress from the temperature.
And here is where you really see the impact. This isn't theory, this is real-world data. At just 37 Celsius, or about 99 Fahrenheit, an EV can lose almost 18% of its range. And get this, that's before you even crank up the air conditioning, which, let's be real, is going to be on full blast. So your 300-mile range car? Poof! You just lost over 50 miles before you even left the driveway.
So the takeaway here is that the consequences are really, really serious. The heat doesn't just cut your range for one trip. It causes permanent damage to the battery, shortening its life. It also raises the risk of thermal instability, which is a very polite way of talking about fires. And if you don't solve this, you risk losing consumer confidence altogether, which could kill the whole transition to EVs in the region.
So, faced with all these massive risks, the region didn't just sit around and hope car makers would figure it out. Nope, they stepped up and created a whole new rulebook, one designed from the ground up for their climate. And this is it. It's called GSO 2698-2022. You gotta remember that name because it's a total game changer. It's a mandatory standard for any EV sold in the GCC. It basically takes the international rules, says, okay, that's a nice start, and then adds a whole bunch of extra requirements specifically to deal with extreme heat.
And this is what makes it so revolutionary. It doesn't just suggest, it mandates active thermal management. You have to have a robust cooling system. But the most radical part, the real kicker, is that last point. The car's battery cooling system has to keep working even when the car is off and parked in the sun. That closes a huge safety loophole that exists in other standards around the world.
And that right there is the big shift in thinking. For a long time, battery cooling was seen as a performance feature, something to help you get better efficiency. This new rule completely reframes that. In the Gulf, battery cooling is now officially a fundamental safety system, just as important as airbags or brakes. It is non-negotiable. So when you have tough new rules, what happens? You get a burst of innovation. All this regulatory pressure has basically forced engineers to get incredibly creative, leading to new hardware inside the cars and even changes to the fundamental chemistry of the batteries themselves.
First up, the cooling systems. The old way of doing things, with passive air cooling, just doesn't cut it in that kind of heat. So active liquid cooling, where you're actually pumping coolants around the battery cells to pull heat away, has now become the new mandatory baseline. It's more complicated for sure, but it's the only thing that really works.
And it's not just the hardware. The battery chemistry itself is changing. For a while, NMC batteries were the star because of their high energy density. But now we're seeing a huge shift toward lithium iron phosphate, or LFP. Why? Simple. LFP batteries are way more stable at high temperatures, meaning they're much safer. It's a classic engineering trade-off. You might sacrifice a tiny bit of range for a whole lot more peace of mind.
And the innovation isn't just happening deep inside the battery. Check this out. Sear Motors, which is Saudi Arabia's own EV company,
developed a windshield that reflects infrared radiation. It basically bounces a huge chunk of the sun's heat away before it can turn the cabin into an oven. A cooler car means the AC doesn't have to work as hard, and that saves precious battery life. It's just a brilliant system-level approach to the problem.
Look, building a car that can survive the heat is one thing. That's half the battle. But how do you make sure that car stays safe and reliable over its entire life as it gets baked by the sun year after year after year?
Well, the answer is ongoing regulation. So the standard itself was introduced back in 2022. But the next really critical phase kicks off in 2025. That's when mandatory annual inspections for all electric vehicles will begin. This isn't just a one-time check when the car is new, it's about making sure it stays safe for its entire life on the road.
And during these inspections, they are not playing around. They'll run tests, like a controlled fast charge, specifically to monitor how the battery handles thermal stress. And there are strict, hard limits. You can see them here. If a battery gets hotter than 60 or 65 degrees Celsius during the test, it fails. The whole point is to catch any degradation before it turns into a safety hazard.
Okay, so you might be thinking this is all just a fascinating story about cars in the desert, but it is so much bigger than that. What's happening in the Gulf is effectively creating a blueprint for what a truly climate-resilient electric vehicle looks like.
And just think of all the other places that are watching this unfold. We're talking about huge, fast-growing EV markets in Southeast Asia, across Africa, and in Latin America. A lot of these regions are facing very similar and in some cases worsening heat and humidity. The tech being desert-proven in the Gulf is directly relevant to them.
And that really brings us to the most powerful idea of all. As our planet continues to warm up, the extreme climate of the Gulf might not be so extreme anymore. It could just be a preview of the new normal for a lot more of us. So the work they're doing isn't just solving a niche problem. It's about being way ahead of the curve. This quote really just says it all, doesn't it? Pushing technology to its limits in the toughest places on Earth, that's not just some weird edge case anymore. It's becoming the smartest way to get ready for a future that's going to demand a lot more from everything we design and build. So that leaves us with one final big question to think about. This whole idea we're seeing with EVs in the Gulf, this concept of building the reality of our changing environment directly into our engineering standards, is that just for cars? Or is designing for the climate that is coming, not the one we used to have? The future of all engineering?